Wanted to work through a few examples of concept questions. These concept questions are covering electricity. They cover electrical charge. They cover electrical conduction. They can cover electrical insulators. Concept questions are about the basic ideas, the basic concepts on which our physics understanding is built. And so in this class, we're going to meet concept questions that will be answered in words, as well as quantitative problems that are answered in terms of calculations and computations. So the first question here says an object receives a positive charge by rubbing, and it asks, have protons, which are positively charged, been added to the object to make it positively charged, or have electrons that are negatively charged been removed from the object? Well, the answer is that electrons have been removed from that object by rubbing, rather than protons being added to that object by rubbing. And it's generally true that when you charge something by rubbing, it always involves the transfer of electrons and doesn't involve the transfer of protons. So if something becomes electrically charged negatively, then it's got an excess of electrons. Electrons have been transferred to it. If something becomes positively charged, then it's lost electrons. It's got a deficit of electrons. Electrons have been transferred away from it. So why is it that electrons are transferred, not protons transferred? Well, the reason is that electrons are comparatively loosely bound to the atoms or the molecules of the material. And electrons are also comparatively very light. So because they're loosely bound and because they're light, they're relatively easy to transfer to and fro between materials. On the other hand, protons are much more tightly bound in the core of the atoms of the molecules that the material is made up of. And also, protons are much heavier than electrons. So for those two reasons, the protons being tightly bound in the atoms of molecules and the protons being heavy, they don't get moved around when you charge by rubbing. Second question. So why do hospital workers wear conducting shoes rather than rubber shoes, insulating shoes, when working with oxygen equipment, when working in high oxygen environments? Well, the reason for this has to do with the fundamental properties, the different properties of conductors in the conducting shoes and insulators in a rubber shoe. In conductors, charge can flow through the conductors. Electrons can flow through the conductors. In an insulator, charge can't flow through the insulator. The electrons won't flow through the insulator. For that reason, for an insulator, charge can build up through rubbing. Charge can accumulate through rubbing, and you can accumulate large amounts of charge over time. On the other hand, for a conductor, charge can't accumulate. Charge can't build up in the conductor because charge will flow away in the conductor. Charge will move around in the conductor. So for rubber shoes, insulating shoes, where charge can build up, it can build up so much that it can be released in a spark in the air. And that could, in a high oxygen environment, cause a fire or an explosion. On the other hand, in conducting shoes, the charge can't build up. So you can't get a spark. So you can't create a fire or an explosion with conducting shoes. Next question says, would the world be different if instead of electrons being negatively charged, they were positively charged. And also, if instead of protons being positively charged, they were negatively charged, i.e., if we swapped the signs of the charges of electrons and protons. Well, you might first think, well, that's something radically different. The world's going to be radically different if protons are negative and electrons are positive. But actually, the world would be no different if electrons were positive and protons were negative. It would be exactly the same as if electrons are negative and protons are positive. In fact, really, our use of our calling of protons being positive and electrons being negative is just a convention. We could equally well have chosen protons to be negative and electrons to be positive. It's just a convention. The important thing is that protons and electrons have opposite charges. That means that electrons and protons with opposite charges will attract one another. And it means that a pair of electrons with like charges will repel one another. And a pair of protons with having like charges will repel one another. And those facts are true. Those incidents of attraction of opposite charges and repulsion of like charges are true whether we call protons positive or negative, whether we call electrons negative or positive. So the important thing is that protons and electrons have opposite charges. Last question. Why do electrostatic demonstrations, in say a physics class, why do they work well on days where the air is dry, but not work well on days where the air is wet, is humid? The reason has to do with the insulating or conducting properties of air. So dry air we think of as being really a very good insulator. On the other hand, wet air, humid air, is a less good insulator. And this affects electrostatic experiments, this affects electrostatic demonstrations. In electrostatic demonstrations or experiments, we typically rely on charging an object or charging objects by rubbing. When we charge an object or objects by rubbing, we want that charge to accumulate and grow and grow, so we can demonstrate the influence, the effects of the electric charge. Well, if it's dry air, then the air does not conduct away the charge. And so that charge on the object that we're rubbing or the objects that we're rubbing can grow. And we can demonstrate electricity, electrostatics. In humid air, the wet air will conduct away that charge as we try and charge an object or objects by rubbing. And so we'll accumulate less charge and be less able to demonstrate the effects of electrical charge and electrical interactions. Anyway, those are a few examples of concept questions in the context of electrical charge, electrical conductors, electrical insulators. They're examples that physics problems are not always quantitative, numerical computations. Sometimes they're about concepts, ideas, principles. We answered all these questions without calculations, without computations. We answered them with words. We answered them with sentences. We answered them with ideas and understanding and concepts. And so that's what concept questions are about.